Okay, in this series of videos, we're going to take a look at measuring yield. Another way of saying that is we're going to look at measuring the returns for bonds, thinking about the returns for those debt security investments. So let's get started here by looking at the idea of yield, which is really just an internal rate of return. So yield is the discount rate that makes the present value of all the future cash flows from an investment equal to the price that you pay up front. So here's a little formula here. From a computational standpoint, we're just going to be using Excel or probably more frequently a financial calculator, but it's good for you to know how to do these calculations in both. Let's look at a real quick and easy example here. A bond is selling for $749.91. It has a coupon rate of 4.5%. If the bond matures in 6 years, what is the yield? And another way of saying that is what is the yield to maturity? That's what we calculate when we solve for that interest rate. So in Excel, we're just going to use the rate function. The number of periods is going to be 6 times 2 because it's a 6-year bond. We got 2 periods per year as our default. The coupon payment is going to be $45 divided by 2, so $22.50. The price is $749.91. We put a negative sign there. Future value is $1,000. We solve for the rate. We need to multiply that result times 2 to get an annualized interest rate, and that answer is 10.17%. In a calculator, it's the same type of deal. So in the inputs, you're going to put 6 times 2, so you'll have 12 for that. The present value, you'll have $749.91 with a negative sign. The payment, $45 divided by 2 to get that number. Future value is 1,000. And then we're going to compute the rate, the I. And we need to take that result and multiply it times 2. So that would give us a result of 10.17%. You should try both of those on your own if you're unclear about how to do those. It's good to get practice. So I would encourage you to pause the video here, make sure you're getting the answers I'm getting, make sure I didn't have any typos or do anything else wrong, make sure you know how I'm getting the numbers I'm getting. So let's move on here. Annualizing yields, there's 2 different ways to think about annualizing a yield. So when you get an interest rate for a period other than a year, there's 2 different ways to annualize that. And typically we're going to be doing this first one, and that's where we just multiply the periodic rate by the number of periods per year. So this gives us a nominal interest rate, or we could also call that the simple annual rate. This is the default way that we're going to report bond rates, and that's called the bond equivalent yield. So when we solve, for instance, in the problem we just did, when we solve for a 6-month rate, we multiply that times 2 to get an annual rate. So we're just multiplying it times 2 to get the bond equivalent rate of 10.17%. That's different than getting an effective annual rate. So that would be this method here where we take 1 plus the periodic rate, raise that number to m, the m power, where m is the number of periods per year, and then take away 1. So the effective annual rate is always going to be bigger than the nominal rate so long as the number of periods is bigger than 1. When the number of periods is equal to 1, then the effective annual rate and the nominal rate will be the same thing. So let's look at a quick example here of these 2 different ways of computing annualized rates. What is the nominal rate and the effective rate if we have a quarterly return of 3.25%? So nominal, we're just going to take the 3.25 multiplied times 4, and that's going to give us 13.00%. To get the effective rate, the effective annual rate, we would take that 1 plus the periodic rate, just like we saw up here. We're going to raise that to the m power, where m is the number of periods, so we got 4 periods per year. Raise it to the 4th power, take away 1, and the result is 13.65%. So these are 2 different ways of looking at the exact same information, right? We've got a quarterly return of 3.25%. There's 2 different ways of reporting that. And depending on the context, we would use one or the other. And I'll make sure it's clear to you what that context is. I'll very clearly specify the effective annual rate if that's the case. Nominal rate will be our default. All right, well, let's move on here. And we've got a few different definitions that we need to be aware of, different ways to measure yield. So there's first the current yield, and that's just simply equal to the annual coupon payments divided by the price of the bond. So that's one measure of yield that frequently investors will look at. Probably the most common one is the yield to maturity. And that is the yield back, if we look back at slide 2 here, that's the yield up here, the Y is the yield to maturity when we solve for that. The yield to maturity is going to be the yield assuming the bond is held to maturity and assuming the cash flows are reinvested at that yield to maturity rate, that same interest rate. So again, it's an internal rate of return that assumes you reinvest it at that IRR. A yield to call is a slightly different animal. Just same ideas, we're just changing one little piece of it. Actually, there's two possible changes to our calculations. So it's the yield assuming the bond is called prior to maturity by the issuer. So remember, with a callable bond, the issuer has the option, not the obligation, to buy back the bond at a particular point in time and at a specified price. So we know that if a bond is called, the number of periods is going to change, the maturity is going to change, but it may also have a call premium. There may be a little bit higher price that the issuer pays when they call the bond, and so it's possible that the final payout may also change. So we can have a maturity change and a future value or a face value change in our calculations. The yield to put is another way of looking at a yield. This has the option on the other foot, so to speak, where the holder now has the option to sell the bond back to the issuer at a certain price and prior to the final maturity. So here the bond is put back to the issuer prior to maturity. We would change the number of years or number of periods in our calculation, and typically you're going to put that bond back to the issuer at par, so that piece will typically not change, but we can still get this yield to put. Let's keep moving here and look at a couple of, actually we're going to look at an example of each. A current yield, we've got a bond with a coupon rate of 4.75%. It's currently priced at $1,107. Very simple and straightforward calculation. $47.50, divide that by the price, $1,107, we get 4.29%. That would be the current yield. The yield to maturity, this assumes, we're going to assume rather, that the bond above matures in 9 years. So we can figure out what the internal rate of return is based on those assumptions. So let's look at it in Excel, look how we would do it. I'm not going to go to Excel in the interest of time. I would again encourage you to go to Excel and work on this, make sure you get the answers that I'm getting. So the first argument is the number of periods. So that would be 9 times 2 or 18 periods. The periodic payment, the periodic cash flow is going to be $47.50 divided by 2. So each 6 months they'll be getting, what is that, $23.75. The price is $1,107. We need to have a negative sign there. The future value is $1,000. We get that result, we need to multiply it times 2 to get the bond equivalent yield, the annualized yield, and that's going to be 3.36%. It is important that you double that rate, that you don't just report the periodic rate that your calculator spits out to you. You need to go ahead and convert that to an annualized number every time. In the calculator, likewise, we would have N is going to be 18 periods. The PV is negative 1107. The payments are $47.50 divided by 2. The future value is 1,000. We would compute the I and multiply that result times 2, and we would get 3.36%. I think I'm going to go ahead and stop here. We'll pick up with looking at these next two examples in the next video, so I'll see you then.